MemSQL is a high-performance in-memory database that combines the horizontal scalability of distributed systems with the familiarity of SQL. Nikita Shamgunov is co-founder and CTO of MemSQL. Nikita, welcome to Software Engineering Daily.
Oh, thank you very much, Jeff.
What is MemSQL?
So in short, MemSQL is a database with the goal of taking every enterprise real time. So that's kind of a high-level marketing message, but what it translates to, it's just fast, scalable SQL. When you say in-memory, it's something that we kind of really started in-memory database, and in-memory is really hyped up right now. But it's really memory first, which means that a lot of operations that we do on the database as we run SQL and especially sophisticated SQL take advantage of the abundance of memory that modern systems have. But the system certainly can handle more data than there is memory.
Have there been some sort of hardware advances that have allowed for memory to be significantly cheaper?
Well, one is just, traditional commoditization curve, and hardware gets cheaper all the time, and memory gets cheaper all the time. But if you make an observation, which I think not only MemSQL but others have done in the past as well, including Mike Stonebreaker, they say, well, let's look at the database workloads and what types of database workloads are there. That was around the famous article of Stonebreaker that one size doesn't fit all. And there's OLTP, which stands for Online Transactional Processing. And then there's OLAP, Online Analytical Processing, which basically flourished into this whole big data market. So you can make an observation that transactional processing systems deal with relatively small amount of data. And what is relatively small? What's into terabytes or tens of terabytes? And today, if you buy an Oracle system or a SQL Server system, I'm going to reference SQL Server when I reference standard databases since I worked there for a long time. You'll notice that you only handle maybe terabytes, maybe tens of terabytes. Now, as you go into OLAP, Online Analytical Processing, you basically start to step into the world of big data. And storing all that data in memory is just not economical, and it's impractical. And the message, kind of the claim is, online transactional processing will end up in memory. Maybe not today, maybe not for everything, but over time, you're going to have relatively small clusters that store all their data in RAM.
You mentioned Michael Stonebreaker's paper, One Size Does Not Fit All. Do you also extend this discussion of one size does not fit all to the notion of polyglot persistence, where most large companies will need multiple strategies of database storage and access?
Well, that's certainly where the market is today, because this claim, the Stonebreaker's claim that one size doesn't fit all, is certainly very, very true. Now, and new database technologies and new database systems pop in, every few months right now. And you have a separate one for time series, you have a separate one for your data warehouse, you have a separate type for scientific calculations. And this is all great because, you have this new technologies popping up, and then there's going to be consolidation and commoditization eventually. But now is a very interesting time. The history lesson of databases is that eventually a single system starts to kind of acquire and grab into other workloads. And so that certainly has been strategy for Oracle and SQL Server. And by 2001, they basically did it. So if you were thinking of data in 2001, and then SQL Server Oracle would just almost certainly solve all your requirements. Now, what happened is people started to collect more data, and amount of data started to grow exponentially. And that started with Web 2.0 companies and then proceeded to Internet of Things and telemetry and all this stuff. And back in 2007, I went to a presentation of Jim's great presentation at Microsoft. So he said, we solved all the data generated by humans, but we haven't solved all the data generated by machines, and that's kind of the next frontier. That certainly became true.
You mentioned Oracle. I read a comparison of MemSQL to Oracle 12c. MemSQL writes to memory first and then to disk, whereas Oracle 12c does the opposite, writing to disk first, then to memory. To put a finer point on the trade-offs between in-memory and disk databases, could you compare these two write strategies?
Oh, absolutely. It actually goes slightly farther than you described in your question. Oracle has so-called in-memory option, which is just a column store index attached to their on-disk table. So, but one step at a time. MemSQL has two types of storage, and that's row stores and column stores. And so does Oracle. Oracle has row stores and column stores. And for MemSQL, a row store has to fit in memory. Not necessarily on one machine. MemSQL is a clustered technology, and so you can have a cluster of machines, but row store data must fit in memory in MemSQL. In Oracle, it's not the case. In Oracle, Oracle tables are stored as B trees, and they can certainly handle more data than there is memory on the machine. Now, it's different for column stores in Oracle. Their column store index must fit in memory. And that's why they're promoting their gigantic machines. I think they're called Spark, but not to confuse with Apache Spark. So in those machines, they have terabytes of RAM. And that's where they suggest customers to store, to leverage their in-memory option. Needless to say, it's millions of dollars for the machine. Now, the write strategy is in Oracle, as you insert a record into a table, the record goes into a B tree, and they also write the record into the transaction log. And as the transaction commits, they guarantee that the data hits the disk. Now, by default, MemSQL also maintains a transaction log, but at the commit time, we do not call so-called fsync. So we don't guarantee that the record hits the disk. That allows us to sustain higher throughput than Oracle. Now, you can certainly configure MemSQL so that it does persist it to disk before it acknowledges a transaction. But that's basically the choice we give to the user and whatever the user wants to optimize for. Go ahead.
So what types of data does a user generally want to keep on disk versus on an in-memory database? Is that a useful distinction to draw?
Yeah, absolutely. So in general, the data that you want to have millisecond access to, you want to keep in memory. Because the moment you throw an I/O operation into the mix, especially at scale, you start to have unpredictable latencies.
So this brings us to a conversation about real-time applications. Could you define what a real-time application is?
Oh, that's a very tricky question. The reason is a lot of people think about real-time, and all of them have different definitions of what real-time is. So if you serve ads, or if you build an iPhone app and you serve data into the iPhone app, real-time is really in milliseconds, because you absolutely have to serve an ad under an SLA, and if you don't, the ad will go to someone else. If you build a phone app, again, if your app is not responsive, then you're going to start losing your users, your customers. And then Google, a long time ago, had a study how their traffic increases, the faster they serve their search queries. And so Google search index is certainly in memory. Now, for analytics, real-time also means kind of different things. So there's a query latency, how fast you get your results as you issue an analytical query. And the query could be, what are my sales, broken down by state. And then there's also data latency, which is some people usually not think about in the first place, but it's a very, very important concept. The data latency is the amount of time this data makes it into your analytical system from the moment it's born. And that goes into the notion of ETL pipelines, extract, transform, and load. And so for many, many enterprises, it could be days. It was certainly about 24 hours at Facebook before the data that's born that makes it into Hadoop and then available for analysts to query.
I did a conversation with Eli Collins from Cloudera, and he talked about something called return on byte, which is where you measure not necessarily the financial return, but basically the value of getting data updated at a certain rate. Do you have any interesting metric sort of strategies for determining where along the gradient of speed you want to present data to people?
So I wouldn't say we have a metric here. What I can say, though, is that there's the notion of the value of data, and the fresher the data is, the more valuable it is. And you can almost have some sort of a graph that represents the value of data of how compared to how fresh it is, and the fresher the better. So most companies care about the last quarter, but also the data that's been generated in the past few minutes is more important than data that's been generated in the past hour, more important in the past day, the past month, the past week, and the past month. And since MemSQL is the real-time analytics space, the workloads that we see are, something in the lines of, A/B testing, where people generate data, throw it into MemSQL, and immediately see their return on investment. Or they push code into production, and they immediately see the impact of that code, which lets them make a decision: should the code be rolled back, or that was a success, et cetera, et cetera, et cetera.
So the proliferation of real-time applications seems to be in part driven by certain fundamental technological breakthroughs. I think a few examples of those are WebSockets and mobile applications. Just the fact that you always are carrying around a mobile application, therefore your state in the network is always being updated by this device that's kind of tracking your behavior. I don't want to say that, not in a negative sense. It's just it's constant data. What are some other fundamental technological breakthroughs, maybe some more subtle ones, that lead to the proliferation of real-time applications?
For sure. So there are industries that are driving real-time usage, and certainly mobile and ad tech are those. The other thing is people have become way more impatient, and I think the likes of Facebook and Instagram and mobile apps enable that types of behaviors. And now people want to have instant gratification and instant response to their actions. So that's kind of on the consumer side. The next frontier is, well, your data centers, your technology should be available 24/7, and that was since Web 2.0, and even more so with mobile, which was not the case in the past, right? In the past, in the financial world, you could be trading during the day, and then loading data into your analytic data warehouses overnight. And that was kind of the business cycle, and it was just fine. Today with Web 2.0, it's just and mobile is just not the case. And then from the technology perspective, there's been a lot of innovations around so-called Lambda architecture and the ability to basically fork data pipelines and use your operational systems that are going in and ingesting data from the same pipeline that's also forked, and you're pushing data into your analytical systems. And that really allows you to both kind of ingest data and query data in real time.
Could you define the Lambda architecture?
So I think I will need to reference Wikipedia for that.
No, your definition.
Okay. So it was defined by Nathan Mars, the creator of Storm. So I might be making mistakes in nuances, but for us and what we see in the market, Lambda architecture is certainly the ability to consume and fork data and pipe it into different systems without a lot of disruption. So, for example, MemSQL works with Pinterest. And Pinterest has their existing data pipelines built on Kafka. And so Kafka just creates this wonderful insertion point where you can say, well, you don't have real-time analytics today, but you have all those Kafka streams. And let us just connect to those Kafka streams, and all your existing infrastructure will continue working. So that's kind of what Lambda architecture enables.
MemSQL is designed for real-time analytics on a changing data set. When MemSQL was first created, what were the existing solutions for users who needed real-time analytics?
Sure. There were some mild real-time capabilities in data warehouses where people would have column store technology, and they would front load that column store technology with some sort of memory buffers and whatnot. People would also be using just traditional relational databases, which works fine for small amount of data and for low throughput, but quickly breaks down in the big data world. So that basically were things around real-time analytics that were present on the market at the moment. At Facebook, people build a project called Scuba, which is a real-time analytics solution built around in-memory as well.
And so MemSQL combines transaction and analytic processing. What does this actually mean?
Sure. So transactionality is just a wonderful building block. So if you are in the Silicon Valley, people can consume a lot of technologies just because they're very, very smart. And they understand the trade-offs, and they understand eventual consistency. They can build application around key values and just basically building blocks of the deconstructed database. That's basically almost the state of big data right now. We deconstructed the database. Now, out there, outside of Bay Area, it is so much harder to consume all the big data technologies because people have existing enterprise applications, and those are built around transactionality and SQL and relational databases. So they don't work for big data, but at the same time, there's no easy to use big data database, and now there is. It is MemSQL.
So MemSQL is making an effort at bridging that gap between all of the technologies that you really need to be in the know about in the Bay Area with the institutions that are farther flung.
Correct. Right. So I can give you a simple example. Let's say you're a big bank, and you have all this security requirements. You have a lot of applications that are doing reporting. that are already built out. Now, imagine that your data grows, and the data grows, doubles every 18 months. And so your traditional database solution, which could be Oracle, which could be Sybase IQ, doesn't work anymore, or it gets prohibitively expensive. So you're like, okay, so I probably need to start using some big data technologies because my data is kind of becoming big. And then you start looking around, and then there's a lot of systems that solve a particular problem. But the problem that you have is, well, I want all my applications to work. I want all my people who are trained and understand SQL very well and understand, data query optimization, indexes, all that stuff to consume technology. But now suddenly you need to kind of completely retrain all these people, throw away systems that understand SQL and generate reports, et cetera, et cetera, et cetera. But with MemSQL, there is a solution that you can basically just drop in with a very familiar interface. And in fact, we even support MySQL protocol on the wire. And you just point your applications at it, and it works at scale.
So I want to discuss that MySQL on the wire stuff. But first, I just did a series of shows on big data, and it was in some sense disingenuous because I don't have a whole lot of experience working closely with big data. I've just basically reported on the processes and the companies therein. And during the week, one of the narratives that developed, but this may be like the narrative developed just because I was imagining it, but I began to get this idea that there were all these managed big data companies, like Cloudera and Confluent and Hortonworks, and if you've got all these different companies managing certain components of your big data architecture, the image that I began to get in my head was all of these different support technicians from different managed big data companies having to interact, and if you have some non-deterministic problem in your data center, it could conceivably become really, really hard because you're trying to synchronize around figuring out the problem while talking to all these different experts who are helping you manage your big data. But so as I said, I think I was actually off on this. Like, I don't think that's actually how the way things work. And considering that MemSQL is sort of one of those almost managed big data companies, could you explain to me what is incorrect, or maybe what is correct about that image that I had in my head?
So yeah, it's a very good question. So if you compare Cloudera or Hortonworks with the companies in the past, so they are kind of the new Red Hat. So there's a Hadoop ecosystem and movement, which is great, and it's very complex, right? HDFS is very, very complex. Hive is very, very complex and has a lot of moving parts. And so, but all those technologies are open source, and a lot of people are using them and trying them out. And what Cloudera and Hortonworks do, they are basically selling you that complexity. They come in and say, oh, don't worry, just sign a contract with us, and we'll navigate you through this world of complexity. And this is a valid business strategy, and that's what they do. So you'll end up solving your business problem, your big data business problems, but you obviously pay for it, and you pay for consulting. You pay for people that Cloudera and Hortonworks provide that help you out, architect, and build your solution. MemSQL is a product company. First of all, MemSQL is closed source. And MemSQL puts an enormous amount of effort for the technology to be easily consumed. So you can basically one-click install MemSQL on your laptop, or you can roll it out on a cluster, which generally is a relatively hard problem. But we'll guide you through that installation just through software. You can spin it up in the cloud, and it's just like instantly available.
So it sounds like with MemSQL, there's less of an intended lock-in or consulting lock-in style business model.
Absolutely. So because we kind of follow the philosophy that everything should be a standard. So we have a standard way of connecting to MemSQL. We support standard SQL. We support MySQL protocol on the wire. There's kind of very little lock-in. The only lock-in that you can imagine is you get hooked on performance and you get hooked on usability. And then from that perspective, it's going to be just hard to switch to something like, I don't know, HBase.
To get back to engineering, could you talk more about the MySQL over-the-wire compliance?
Sure. So we do not compete with MySQL. MySQL, and I actually have an answer on Quora about precisely that question. MySQL is a great technology for what it does, which is a single box transactional database that is very, very easy to use and deploy and understand. For us, supporting MySQL Wire protocol is basically drivers, right? The drivers are very well implemented for MySQL, and they're everywhere, and usually they even pre-installed to a large number of systems. And so supporting that just allows us to plug into this enormous ecosystem, which is, products like SQL Pro for developing your applications, Tableau for BI, MicroStrategy for BI, clients for Python, Ruby, and Java. And so we can just leverage all that ecosystem and not have to go and build a driver for every single integration that's out there. And that's an enormous amount of work.
I see. So are you saying that you, instead of writing a layer of compatibility with MemSQL for Tableau and all these other things that you would normally have to write some sort of driver, some sort of communication layer between MemSQL and those pre-existing solutions, you just essentially went lower level and put in a layer of compliance with, I shouldn't say put in a layer, you implemented the compliance with MySQL. If you think of MySQL as an interface, you implemented that interface. So now everything that needs to communicate with MySQL can communicate with MemSQL.
That's right. That's precisely right. That was, we've made a few mistakes, obviously, early on, like any other technology company, but that was a great decision for us.
So what were how difficult, that sounds like it's pretty challenging. Because MySQL is this really proven technology. I know nothing about the spec of the interface, but I imagine it's pretty difficult to implement that compliance. Could you talk some about that engineering process?
Sure. So there are actually layers of compliance. So the protocol itself, the network protocol itself, is something that's a relatively straightforward task for a systems engineer. So you read the spec, you understand what bytes you put on the wire, and you just go and follow that spec. There are some quirks, obviously.
So you're saying it's not that hard. It's more like you just have to have this insight first, and then you do it.
Yeah, and then you do it. The harder part is supporting what it's called system variables and information schema and all these commands that go beyond just the wire protocol, right? So I'll give you an example. When a typical application connects to MySQL, it establishes a kind of network handshake, sends a few bytes back and forth, and says, and now that, okay, we have this connection. But the second thing, they usually send a few commands, like, and what are the databases in the system? And which collation you support? There could be a few kind of commands that you need to support in order to plug into existing MySQL tools. But once you implement those, then it's wonderful.
So if I've built an application that uses MySQL, what is the migration process to MemSQL?
So that goes back to my remark that we don't really compete with MySQL. So, and we do not kind of replace MySQL application.
Okay.
And the reason to this is this is cluster technology, and it kind of solves slightly different set of problems. It certainly is possible to move from MySQL to MemSQL, but that might require you to do some schema changes and possibly some query rewrites that come with the understanding that you not only have tables and indexes, but you also have data distribution, and you need to keep that in mind.
So if I add MemSQL to my system, is it replacing something like Oracle, or is this simply like something that augments your database solutions?
We often see augmentation. That was our story with Pinterest. But we also see replacement of really high-end systems, such as Oracle Exadata. So the reason people buy Oracle Exadata is because their performance requirements are such that the traditional Oracle database cannot keep it up. And so they go and buy this like massive iron appliance. And then once you make this leap, you can make even further leap and say, okay, well, I want to try a scale-out technology that runs on commodity hardware for my application. And then they try that, and they see massive performance improvements, and also it's much cheaper.
How does the onboarding experience compare with users of AWS or Azure or on-premise? Maybe you could just talk a bit about the onboarding experience as a whole.
Absolutely. So we think about those things as distribution channels. And if you want to spin up MemSQL on AWS or Azure, you can go to cloud.memsql.com, fill out a small form, and then it will drop you into AWS interface where you just need to log in with your credentials, click a few more buttons, and then that's it. The cluster is up and running. We also integrate with Azure and AWS marketplaces, but those are what we call clusters in a box. So this is something that allows you to, basically play with the technology and understand it in a kind of constrained environment. And then once it proves value for you, you can go and create a much larger cluster. 10, 20, 100 nodes. We also integrate with Mesosphere. And so in Mesosphere, you can basically drag and drop MemSQL and create a cluster as well. Now, integrations are great, but people also want to run it on their laptops, and people want to run them on premises, on their hardware, or on virtualized hardware in VMware. And so we put a lot of effort into creating an installer. Basically a system that you can run on one server, and then it drops you into a graphical UI, web UI, where you can add SSH keys and IP addresses, and then click next, 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 and kind of voila, you have a cluster running on 100 nodes inside your private data center.
Apache Spark is an in-memory processing engine that is iconic of the movement towards real-time applications. How do your users, and how does MemSQL leverage Apache Spark?
This is a very good question. So it's very much complementary technology to MemSQL. So Apache Spark does not have any persistence, and it does not have any transactionality. It does not kind of have a serving layer. At the same time, Apache Spark has streaming, and Spark streaming is a wonderful technology that we see a lot in the market. And so what you can do is you can leverage Spark streaming to subscribe to data pipelines, kind of going back to this our early conversation about Lambda architecture, transform the data, and then push that data into MemSQL. And the reason you want to push your data into MemSQL because MemSQL kind of has persistence, so you can store that data in the database and makes this data available for analytics immediately.
Go ahead.
Yeah, so this is basically kind of the vanilla example how MemSQL interacts with Spark, and specifically with Spark streaming. The other thing is that our customers use with Spark is analytics beyond SQL. So we put a lot of effort into making distributed SQL work really, really fast and efficient. But SQL is an API that is very powerful, but also constrained. And with Spark, you can go and do analytics beyond SQL, things like machine learning and data science and so on.
So, correct me if I'm wrong, but I think I read somewhere that MemSQL can be used to augment Spark with kind of an ACID compliance type of model. Is that correct? Maybe I misread that.
Of course. Yeah, of course.
Oh, no, that's right.
Yeah, MemSQL has ACID, right? So you can do, begin transaction and then do a whole bunch of stuff and then decide if you want to commit it or roll back.
Right.
And
so if I have ACID compliance together with Spark, how does that change what I think of as the database?
So if you think about a database, ACID is very important. That's basically almost kind of synonym, not synonyms, but kind of ACID usually comes with a database. And what it lets you do is it lets you kind of control the way you change the data in the database. Spark is read-only. It's built around the notion of RDD, resilient data sets that are immutable. So this immutability kind of goes through this whole design of how Spark performs the computations. And so that's why those technologies are very much complementary.
So I just did a show, like I said, I did a series of shows on big data, and one of them was about Spark. And throughout these shows, there was a theme of companies migrating from completely batch architecture to an architecture that usually had batch and streaming. Tell me more about how you see this shift occurring, and whether is the eventuality completely streaming architectures, or is that missing the point? How do you see this shift at MemSQL?
Sure. So let's say you have batch, right? So you live in the world of, let's say Hadoop, and you're running MapReduce jobs. Now then, there's a very natural kind of transition to keep certain computations in batch, because maybe they're large-scale computations, or those are kind of computations that you don't care about, you don't want to put all the data in memory and whatnot, and you just keep using Hadoop. And then you augment those with much faster computations that you do in a streaming manner. And streaming is also a word that could be used in many contexts, in different contexts. But yeah, so with Spark, you can perform those computations more efficiently because the computations are streamed or pipelined. And then with Spark, you can also go and subscribe to data streams for the data that was just born a few seconds ago, and leverage that data for your computations as well. With MemSQL, the similarity is the way of performing computations. So all the computation that MemSQL does are kind of pipelined. So we do not do this MapReduce stop-and-go operations. And with MemSQL, you can persist your streaming data and make this data immediately available for analytics. So that is kind of the difference between Spark streaming, let's say, and MemSQL.
And Spark is the most popular streaming solution. How does Spark compare to Apache Storm or other streaming solutions? Why is Spark been exponentially more popular and more talked about than these other streaming solutions?
Well, I think it's the API. So Spark's API is wonderful and is so easy to program against Spark.
Yeah, that's exactly what Matei Zaharia said in the interview that I did with him.
Yes, and and this is great. From a SQL perspective, the success of Spark is a very, very good thing for MemSQL, because this means that people are doing more and more real-time computations and leveraging streaming and subscribing to data streams. And once you subscribe to data streams, you need to put data somewhere. And you need to put data somewhere which enables you to do interesting things with the data, either serve it or further analyze, or persist it and attach Tableau to it and stuff like that.
What I think is so interesting about that is the fact that Spark kind of won on the back of a well-designed API, and not like a fundamental breakthrough, like, oh, he does this amazing thing with directed acyclic graph structuring or something. It was all about the API, which I think says something about engineering. Do you focus a lot on, like, what is the developer experience? What is the API at MemSQL?
Yeah, absolutely. And so our API is SQL. It's a structured query language that a lot of people understand. So if you type SQL on LinkedIn, you will have probably hundreds of millions of people. Actually, let me make this experiment. SQL. Typing it on LinkedIn. Yeah, there's just enormous amount of people that know SQL.
I love the on-the-fly usage of LinkedIn. That LinkedIn as the search engine. I remember hearing an interview with Reid Hoffman a while ago where he was talking about how people don't utilize LinkedIn in the interesting ways that they could, but it's great to see you doing it on the fly.
Yeah, that's right, and that just shows how many professionals know SQL. Yes. SQL is a standard. The interesting thing about this SQL as an API is that.
Wait, did you get the number back, by the way?
5,657,000 people results for SQL.
That's pretty good.
Yeah, and if you type SQL in Google, you will
sure.
get like probably insane number.
Right, or Google Trends.
Yeah, 239 million records.
Google Trends would be interesting. I wonder how SQL is tracking against NoSQL.
Okay, so let's type NoSQL. And so you get 10 million results.
Huh.
So wait, 10 million results.
You're saying versus... on LinkedIn? On LinkedIn you get 10 million?
Oh, that I got on Google. So on LinkedIn,
okay.
Let's type NoSQL. And we have people 72,000.
Wow, okay. So yeah, SQL crushes NoSQL. I guess right. NoSQL is less of a skill. It's like, I do not have the SQL skill.
That's right. So SQL is just out there and it's not going away. There is a Quora question why people still write SQL. And I have an answer there, and then there are other perspectives from other people there as well.
Okay, I'm going to put that in the show notes.
You can also look at how all the NoSQL companies are implementing SQL now. So Couchbase is introducing a SQL layer. Well, obviously, Hive and Impala and Presto and Hadapt are all introducing SQL. Because SQL is just a very good language and API for data. And when people say that SQL doesn't scale, it's kind of hard to, it kind of doesn't make sense because it's just saying API doesn't scale. It's usually the underlying technology that does or does not scale. And so what we did, we took this most popular API, which is SQL, and we made it scale.
Yeah, and it's funny. There's a great Google talk that I'll also include in the show notes, where it's like a comparison of one of Google's distributed SQL solutions versus a distributed NoSQL solution, and it's like these two guys are giving the presentation, and they're sort of giving these two competing presentations at the same time, and the punchline is just that like they're both basically offering the same thing. It's just one is NoSQL and one is SQL. So
yeah,
anyway.
that's right. Yeah, so back to the API. So the API is the language, but also what people kind of enjoy when they use SQL that's written against a mature system is that it's very, very forgiving. And what I mean is when you write a bad program, it doesn't perform. But many times when you write bad SQL, it still performs. And that's because there's a query optimization step that requires a lot of engineering that chooses a very efficient query execution plan. And that's the maturity of SQL, and that's why it's really hard to make a really good SQL system. So what we did is we hired, the incredibly great database engineers out of Oracle that built our query optimization.
Good strategy. So the field of data science is exploding lately, and Matei Zaharia, the creator of Spark, started Databricks, and that actually has the stated mission of improving data science. Why is data science so important? And maybe you could define what you see as data science.
Sure. So we live in the database world, right? And we see data science not quite front and center, but on the periphery of the what people want to do with data. But I think data science is kind of the generation of insights and understanding data, understanding specifically large data sets, right? That could be structured, that could be unstructured. What people use MemSQL for when they tackle data science problems is that scalability and persistence and the ability to deduplicate the data inside the database. What they don't do with MemSQL is they're not writing kind of complex ETL, extract, transform, load jobs, or they don't do data cleaning. And those are the things that you can do with Spark. So again, those technologies are very complementary.
And I see a unique property of the American economy is that we have a lot of overeducated and underemployed people. And like I can think of a lot of people I know who have 4-year degrees and are working in a coffee shop or as a copy editor. And I look at these people and I'm like, these people should be data scientists. Like if we were running the economy the way we should, they would be doing data science. So first of all, I guess, do you agree with this? And how can we make data science easy and intuitive enough for these types of people to leverage the tools?
So do I agree that baristas should start doing data science? Maybe not. So when you say that an overeducated person works at a coffee shop because that person cannot find a job in and leverage the degree that he got at school, then yeah, but maybe the answer is right. But it might not be a data science, right? He might go get another degree in something that's the modern economy really welcomes, and leverage his skills or her skills there. But I think you touched on an interesting point that data science is a hard thing right now, and the reason to that is it's still not as mature as other things, which creates interesting opportunities. First of all, technology is going to get better, and technology is going to get more consumable, and technology is going to become easier to use, scalable, faster, and more pervasive. And certainly becoming a data scientist today is a great profession, and there's a lot of demand to it. What I think is going to happen is technology as industry will be pulling more and more people in itself, and that's just going to be a result of the economic incentives of going and investing in new technology skills. And data science is just one of them.
What I see as this interesting tension is like data science in its current form, a lot of what it does, like think about what Palantir does, it's like it surfaces insights in a way that makes it easy for the human to pick out what are the relevant insights to focus on. And but you think about it like, okay, so does data science grow as a field where we have more and more data scientists who are picking through these types of things and like finding the edge cases, or does the technology get good enough where we don't need that human augmentation and the computers themselves can pick out the outlier situations?
Well, it's all about productivity, right? So it's, when you look into software engineering, when you look at data science, there's still people doing the work. It's not machines, but they use machines as tools to make what they do day to day more efficient. Every time something new comes out, people, what will be a good example in the past? Well, since we're talking about data processing, that before relational databases, people had data problems. And they were solving those data problems by writing programs in COBOL or C, and that was just not efficient. And then relational databases came in, and you can write SQL, and it's so much easier. And the result of that you just saw on LinkedIn by doing the search of SQL. And I believe that every industry will have this kind of, would it be fair to say, commoditization curve, where it becomes so much easier to use, but then the skill will become, in a way, less valuable because it's just easier to use, and so that's why it's not compensated well enough.
So MemSQL Ops is the command center for provisioning and administering MemSQL clusters. I think this is a good point to transition into, as we were discussing the human-computer interaction and the increasing productivity. What is the role of MemSQL Ops, and who is using it? Like, is this the DevOps side of MemSQL?
Yeah, absolutely. So if you look at system software that's kind of modern, every system software, we can talk about Nutanix, we can talk about data stacks, Cassandra, usually comes with a dashboard, and it's an ops dashboard that lets you kind of glance over it and understand how the system is performing. And that's exactly what MemSQL Ops is. The difference of MemSQL Ops and other dashboards is it kind of exerts this real-timeness of the technology by showing some of the metrics that of the cluster in real time. So basically, it shows you CPU utilization, network utilization, and displays it right in front of you and updates it every second.
So to begin to close off, could you talk a bit about MemSQL's business model?
Sure. So MemSQL is a closed source technology, and we're not really religious, right? So we certainly consider making MemSQL open source and understand what it would mean from the business perspective. And so keeping it closed source allows us to be a technology first company and a product company. What it means is that we have way more engineers than we have consultants. Certainly, we have a sales engineering team that helps our customers with onboarding the product or engage with really large projects with the like of Comcast, for example, or big banks in New York. But most of the engineering effort goes into improving the product, making it easier to use, and making it scalable. And that's what the business model is. The business model is to create a great product and sell it through different channels such as cloud, direct sales, and direct enterprise sales. And we also introduced our community edition, which is free forever with unlimited scale. And then we encourage the world to use MemSQL, and those who want support and enterprise features such as enterprise security, they certainly go and convert into enterprise customers.
Yeah, and I think what you're articulating is something that was touched on during Big Data Week, which is basically there is no free lunch. You can have this open source consultancy type of solution. It's not, in a nutshell, better or worse than MemSQL's type of company offering. It's just there's a different set of trade-offs. So, Nikita Shamgunov, thank you so much for coming on Software Engineering Daily. It's been a real pleasure talking to you.
Thank you, Jeff. And don't hesitate to send me more questions. I'm very available on email and other forms of communication.
Fantastic. Well, great talking to you. I'll talk to you soon.